Okay, so welcome to this. This is the Further Math Support Program online revision session for OCR Statistics 1. And in this session we're going to look at some of the finer points of probability. Now I'm going to concentrate mainly on permutations and combinations and maybe a nice approach which is more pictorial to help you see what's going on with here. So we need to be able to use permutations and combinations when dealing with selections, repetitions and restrictions, and I've got examples covering all of those. And again, I'm going to show you a sort of more pictorial way of dealing with these. We have to understand addition and multiplication of probabilities to do all of this, of course. We need to understand informally, not in any detail, independency and also conditional probability, i.e. if a probability depends on something else having happened, then how do we calculate those? So, January 2011, question 6, we have a situation where we've got 7 cards and we want to look at how many different 7-digit numbers we can form. Now, we have to understand that there is some repetition here. 3 occurs 3 times, 5 occurs twice. So one way of doing this is just to completely ignore the repetitions and worry about them later, which you are allowed to do. So if we think about it, there are 7 ways of filling the first digit. Okay, there are no zeros, which is quite nice, so 7. There are 6 ways of doing the second, because there are 6 cards left. 5, 4, 3, 2, 1. So in total we have 7 factorial, multiplying all of these together, 7 factorial ways of doing this. And if you work that out, there are 5,040 ways of doing that. However, we have to also realize that there are repetition. Okay, so based on that we then have to deal with the fact that the 3 can occur 3 times, so there are going to be lots of repetitions. So the way of dealing with that is to realize that the 3 factorial ways, there are 3 times 2 times 1 ways that all of these 3's could themselves be arranged. So that means there are going to be 6 possible combinations that are all the same. And we use the same argument for the 5's as well. Okay, the 5's, there are 2 5's, so there are 2 possible ways that this can happen. Okay, so dealing with that, we can then just divide through. So we're going to have 5,040 divided by 6 times 2. Okay, and if we do that, that's going to give me 420 possible combinations. So in other words, we're looking for, there are 7 factorial possible combinations, 3 factorial repetitions for 3, 2 factorial repetitions for 5, and that's going to give me the same answer. Okay, so working that through, you get 1 mark for recognizing that we've got 7 factorial. You then get another mark for effectively dividing through by both of these. Okay, and then an accuracy mark at the end for that. Okay, so in this question, this part of the question, we've got a slightly different setup in so much that we've got 5 white cards and 10 grey cards, and each one of them has a letter on it. And what we're asked to do is from these 3 cards, 3 white and 4 grey are selected at random without regard to order. And that's the really crucial thing. We're not interested in whether they come in a particular order, it's just choosing them. And we're asked to say how many selections of 7 cards are possible. Now, I think the easiest way of doing this, actually, is so you can see, is to draw something again. So I want to choose 3 white cards, and I want to choose 4 grey cards. So without any sort of thinking about it, there are 5 ways of choosing the first white card, because there are 5 of them. I've chosen one, so there are now 4 ways, and 3 ways. Whereas with the greys, there are 10, and then 9, and then 8, and then 7. Okay, so that is a really nice way of doing this. Now, because of the combinations, we're basically multiplying all of these together. Okay, which gives me 2,100. Okay, if you want something a bit more formal, what we're saying is we're choosing 5. From 5 things, we're choosing 3, and from 10 things, we're choosing 4. And that will give you exactly the same answer. Okay, so where marks are awarded for this is you get 1 mark for either writing 5 choose 3 or realizing that it's 5 times 4 times 3. You then get another method mark for using 10 choose 4, or again using 10 times 9 times 8 times 7. And then your final accuracy mark for this question is to work them out. Okay, So that's quite a nice question. Again, drawing things is quite useful. So now we're after the probability that of these 7 cards, exactly 1 is showing the letter A. So we know that whatever we do is going to be out of 2,100. So again, drawing stuff is really useful. So this is a restriction that we're talking about. Now, 2 things can happen. So either you have an A here, okay, happy with that? Good. Or you have an A in the next set instead. Okay, so we need to think about how this works. So to do this, we've put an A in. There are now only 4 choices for the next one and 3 for the next one. Now I can't have an A in the next slot, pure and simply because they now have 2 A's and we want exactly 1 A. So there are 9 times 8 times 7 times 6 other combinations that we could use. Okay, and that's really important. In this combination, we've got A times 9 times 8 times 7. And then on this side, we've got to realize that, again, we're not allowed an A. So we've now got 4 times 3 times 2. Okay, so the A is fixed. There's only one way that that can happen, really. So that's the sort of way that we can deal with that. So here, let's just think about the maths. We're choosing, because the A is fixed, we're really choosing from 4 things 2 items, and then we're choosing from 9 things 4 items. From the second one, we've got 4, and we're choosing 3 items from them, and then the second one we've got 9 items, and we're only choosing 3 in that particular case. Okay, and what we're going to do is then add those together. So that gives me 1092. So to work out the probability, it's going to be 1092 divided by 2,100. So that's going to give me as a full answer 0.52. So again, drawing something enables you to see what we are required to do due to fixing. Okay, so that's quite nice. That's quite pleasant. So your method marks come from, you basically get 3 method marks for coming up with this statement here. Okay, your first method mark really is for working out the first combination set. The second method mark is for working out the second combination set. And the third method mark is for then adding them together. Okay, now there are loads and loads of other ways of doing this, but I think again pictorially, I think this is quite a nice and sensible way of doing it. So, moving on to a more sort of just probability question, we've got a table here that shows the numbers of male and female members of a vintage car club. Now, it's a 2-way table. Okay, they either own a Jaguar or a Bentley, and no member owns both. So they're independent. So I think it's always a good idea just to add these up. Now with these questions, again, it's just about thinking logically. So one member is chosen at random, and I want to know, given that they are male, find the probability that they own a Jaguar. So I'm only interested, because it's a given that, I'm only interested in males. So the way we write this is the probability that he owns a Jaguar given that he's male. Now there is a formal formula, which is basically this. I want to show you that this can come, and if you use it, then you've got 25 people who are Jaguar and male, and 37 who are male. A different way of thinking about it is to realize that I'm only interested in 37 people because they're the males. Of those 37, 25 have Jaguars. So there is a formula way, but there's a more sort of reasoning way as well. Okay, so you get 2 marks here. You get a method mark and you get an applied mark, an accuracy mark, sorry, and then it's just working it through. So you get 2 marks, and basically it works as 1 mark for the numerator, 1 mark for the denominator. So that's quite pleasant. Okay, so let's just add these up again. 23, 60 in total, 20 there and 40 there. So given that the first one was female, find the probability that they both own Jaguars. So we're choosing 2 people here at random, and they're chosen 1 at a time, and you're choosing them without replacement. So we're told that the first person who chooses a Jaguar must be female. So in other words, out of the 23 females, 15 of them have Jaguars. So that's the first person dealt with. The second one, I'm now interested in whether they just own a Jaguar. Well, I've taken 1 person out, so instantly I've now got 59 people. I'm down to 14 females, which gives me 39 in total. So I just want somebody who's now got a Jaguar, so that's going to be 39 out of the remaining 59 have a Jaguar. So that would be all that's required there. So just to look at this before we do the final answer, you get a mark for this, you get 2 marks, one for the numerator, one for the denominator, and then again you get your final accuracy mark at the end. So it's just about being logical with these questions. Okay, so moving on. We've now got a situation where we have a washing up bowl containing 6 spoons, 5 forks and 3 knives. And 3 of these 14 items are removed at random without replacement. And we're asked to work out the probability that all 3 of these are different. Okay, so this is question 5 actually. So let's change that to question 5. So to do this, we again just think about what's going on. So if they're different, you either have a spoon, fork or knife, or you have a fork, knife or spoon, and so on. So there are actually lots of combinations. But let's just start looking at this. So let's say we choose a spoon. So there are 6 out of 14 spoons. We then have to choose 5 out of 13 for the forks, and we have 3 out of the 12 for the knives. So that's just doing it in the order that they appear. Now if I think about doing this with any other combination, so let's consider doing 5 out of 14 forks, and then 3 out of 13 knives, and then 6 out of 12 spoons, you'll realise that actually these are entirely the same fraction. So we just need to realise how many ways are there of choosing 3 different things. Well, if you think about it, we've got 3 objects that are all different, so there are 3 factorial ways of dealing with this. So the answer in total will be 6 14ths, excuse me, 5 13ths, 3 12ths, times by 3 factorial. And that's going to get you quite a lot of marks on this question. Okay, so you've got both of your method marks, one for finding the single probability, and then one method mark for realizing that there are 6 possible combinations, all with the same probability, of course. And that leads rise to an accuracy mark for the correct answer. This time we're looking at all 3 items are the same kind. So we've got a spoon times a spoon times a spoon, or we have a fork times a fork times a fork, or we have a knife times a knife times a knife. Now of course these are all over the same fraction, which is 14, 13 and 12. So that's actually a really pleasant question. Okay, there is another way of doing it. You could say I'm choosing 3 from 6 spoons, or I'm choosing 5 from 3 knives, forks, sorry, or I'm choosing 3 from 3. And then you would need to divide that by the fact that you are choosing from 14 things, you're choosing 3. So they are actually identical. As I say, I personally find the left hand side a lot easier to manage. So if you work that out, we get 31 over 364, or if you want decimals, 0.0852. So the way that your marks work here is, again, you're going to get 2 method marks, okay, and your method marks are going to come from any one of these little sections correct. So if that's correct with the correct denominator, then you're going to get a method mark. If all 3 are correct, all 3 numerators are correct, then you're going to get your second method mark. Okay, and don't forget this is without replacement, so you've got to be really, really careful with that. And then of course an accuracy mark at the end. So again, another nice question. You just need to sort of think about what's going on. And then finally, we've got June 2011 question 6. This is quite a tricky question, which is why I've done it. So we've got a group of 7 students sitting in a random order on a bench. Find the number of orders in which they can sit. So here, again, we're just thinking about 7 compartments. So 2, 3, 4, 5, 6, 7. And I'm not really interested in any order. So we've got 7 people can sit there, 6 people, then 5, then 4, 3, 2, 1. And we can see that that is going to be 7 factorial, which is, as a previous question, 5040. Okay, then it's part B, so you just get 1 mark for that, one independent mark it's called. Now part B is a bit more entertaining. We've got 7 students, include Tom and Jerry, and they have to sit next to each other. So you can either, the way of doing this is to lump them together. So TJ, let's treat that as one person. Okay, so there are now 5 more places to fill. Okay, so TJ fits 1 place, and of course that could happen. So if you think about boxes, there are 6 ways you could fill the first box. Doesn't have to be with TJ, could be in any order. There are 5 ways of filling the second: 4, 3, 2, 1. So if you treat T and J together as a single item, that's how many different ways there are of doing it, which is 6 factorial. Now the interesting thing is, they just say they have to sit next to each other, so you could either have TJ or JT. So in fact actually there are twice as many options as we've stipulated here. Okay, so it's 6 factorial times by 2. And again, if you simplify all of that, we're going to end up with 2 over 7. Okay, so you get a method mark here for recognizing that it's 6 factorial. You get another method mark for realizing that TJ and JT means that you're doubling up how many possible options there are. And then you get an accuracy mark for the final bit. Now, students consist of 3 girls and 4 boys, and we want to find the probability that no 2 boys sit next to each other. Now, you have to think about this quite hard, but what you come to is the conclusion that this can only happen if the following occurs. It can only happen if your sitting is boy, girl, boy, girl, boy, girl, and boy. Now, leave it as an exercise for you to convince yourself that if it's not that order, you will always end up with 2 boys sitting next to each other. Okay, so we could just go through the probabilities of this. So the first slot, okay, there are 4 boys out of 7. Then there are 3 girls out of the remaining 6 people. There are then 3 boys out of the remaining 5 people, 2 girls out of the remaining 4 people, 2 boys out of the remaining 3 people, 1 girl out of the remaining 2 people, and then 1 boy out of the remaining boy. Okay, and again, I think that's probably one of the most simple ways of tackling this question. The great thing is, as well, that things start to nicely cancel as well, which really makes life a lot easier. Okay, so we actually end up with 1 over 35 as my answer. So for the part A, you sort of do have to realise that this is the only combination that you're allowed. Okay, there are other ways, but again, I think this is the clearest way of seeing what's really going on with this. Okay, so 2 marks. You get 1 method for demonstrating what you're doing, and then you get an accuracy mark at the end. Now, we've now got to consider all 3 girls sitting next to each other. Okay, so again, we'll think about that as a block of girl, girl, girl. Okay, and then there are 4 boys individually. So really there are 5 objects here. So I know that there are 5 factorial ways of combining these together. Okay, that will guarantee that all 3 girls sit next to each other. Okay, so that's quite important to start off with. We then have to realise some things. So we also need to realise that if we then look at the block of 3, there are actually 3 factorial ways that all of these girls could arrange themselves as well. So in fact, there are 5 factorial multiplied by 3 factorial possible combinations that allow you to have this particular setup. Okay, because again, all the boys can permute between themselves as well. And what we're looking for is the probability. So in total, there are 7 factorial ways that this can happen. So what we can do is set this up. So we've got 5 times 4 times 3 times 2 times 1 times by 3 times 2 times 1 divided by 7 factorial. Of course, you could do this on your calculator, but actually sometimes it's a bit nicer not to, in my view. So we can see lots of things are going to start cancelling. The 4 cancels with the 4, 5 with the 5, the 3, 2 cancels with the 6, and we end up with 1 over 7 as the answer. So for this, you're going to get 1 mark for finding, effectively, the fact that we're dealing with 5 factorial if you do it this way. There are other ways. Okay, you then get your 2nd mark for then multiplying it by 3 factorial because of how the girls themselves can permute themselves. Then dividing it by 7 factorial and getting 1/7 will give you the final answer. Okay, so My advice with all of these questions is people find combinations and permutations and restrictions in particular very tricky. If you think about drawing what you've got, then sometimes you can get to the answer in a less formal way, but actually it is a bit clearer for you to see what's going on.